Welcome, welcome, welcome. It's good to be here. I'm going to do a little bit of an overview of who we are in case you're just wandering by and you're curious what is happening at this booth. We are Merck, KGaA, Darmstadt, Germany. In the US, we are known as Millipore Sigma, EMD Serono, and EMD Electronics. EMD Electronics is the one who's hosting this booth here. We are a 357-year-old company in Germany. We're the oldest pharmaceutical company in the world, but we do a lot more than pharma now. So we have any of the reagents that you see in any lab to do any kind of scientific experiment. We are at the core of all of the technology that you see here. Historically, a lot in the display layer, and now very much in the chipset underlying it. Our goal is sparking discovery and elevating humanity. We are a company of nerdy scientists who love to create amazing things. For me, one of the things I think is not discussed as much about our history, but is really important to what we do on the EMD digital side, is in May of 1851, Emmanuel Merck put the first guarantee on a bottle of reagents. And it sounds very, very simple, right? Very basic, that I personally guarantee the purity of my preparation. But it's critical for science and for scientific reproducibility. Prior to this, you had no idea if the thing that you were using was actually this thing. And I view this sense of quality as being something that is more and more existentially important. And I'll have my good friend Alex coming up and joining me in just a second here. We've talked a lot about this over the last few years. We've had a number of interesting technology waves and just distribution of proliferation of technology. If we go back to 1980s to today, the average bandwidth per household has increased by about 50% a year, every year. It's 10% less than Moore's Law. We had the last 10 years, 92% reduction in the cost to transmit a megabit of information. And information distribution has just gotten unbelievably fast and unbelievably cheap. And in 2010, we came up with something incredible. We monetized eyeballs with online advertising, and it led to this huge amount of information being created, consumed, and distributed globally. And it led to a lot of kind of scary information that was coming up, but we were incentivizing it. Throughout that entire time, we had Moore's Law just continued to tick along. Compute continued to become cheaper and more powerful. And when we combine this massive amount of information that's available with this compute that you can do something with, you wind up with the LLMs that we're seeing today, and the generative models that you see today. And this means that we're now at this point where information creation is now unbelievably easy to create and distribute. And the need for an ability to pull back and see where did information come from becomes existentially important. And that's exactly what we do on the EMD digital side. It's, can we create this bridge of quality for information and tracing it back? Can we take a data point and trace it back to source system and validate the source system itself? So we've got two fun portions here. The first one is I'd like to introduce my good friend Alex up. We're going to have a chat for about 20 minutes or so, and then we'll have a fun discussion on mTrust. Yes, a few words. Alex was kind of a Google legend. He created one of the great guides for new Googlers as they were onboarding as a product manager there. He was the head of strategy at Stripe for a few years and just co-founded Common Tools, and I'll let him talk a little bit about that when he comes up. But Alex, please come on up. And I mean, we met 3 years ago at a Google conference in Paris of all the APMs, and had a long discussion specifically on the sense of information creation or information distribution infinitely fast, infinitely free, information creation infinitely fast, infinitely free, and this almost like existential sense of, in existentialism, there's this sense of meaning and authenticity as like the critical human factor. And so as we look at like the human and the AI side, the human is such a critical part of this that I think often doesn't get discussed as much,
Yeah, I think it's one of those things. And by the way, this is missing a couple of words. Former head of corporate strategy at Stripe, not head of Stripe.
That's correct.
Just for the record.
Yeah.
I think when you look at, from cost comes meaning to some degree. The fact that you choose to invest the cost in a thing gives that thing that you produce a fair bit of meaning. And as the cost of that production continues to decline, and it becomes incredibly easy to make AI-generated slop, you get a cacophony of background noise of just kind of middling stuff. But I think there's a depressive view of this, which is just that we're going to be inundated with never-ending AI-generated slop, which I think is probably to some degree is going to happen. But I think there's also a possibility in this world to have a new style of co-creation with AI. And so one of my friends I was talking to a while ago is like some guy in tech, and he was telling me about how he uses, he's like, yeah, I started writing poetry again. I did it in college. I haven't done it for decades. And I started writing poetry because I could work with Claude. And I could just talk back and forth about a theme I wanted to capture or try to tweak it. And I think that's a great positive example of the kind of value that comes when you have a co-creative partner as an LLM that allows you to reduce the cost of exploration and discovery as an individual.
Oh, I completely agree. I think we have like a renaissance that's coming on just like creative arts in general, right? Because this idea that there's like this judgment-free creative partner to be able to work with and do it. I mean, we were talking earlier, I spend a lot of time making songs with this on different topics. Currently working on Mr. Magoo's parents, how they met. Kind of curious.
Untold story.
But where else would you have the time to be able to put something together like that and do it? It is genuinely extraordinary to see it, and how the improvement has come and how it's changed is just wild to me. Now with that, you also have a couple of curses from like a technology standpoint, right? Like there's this curse of recursion where I still find it fascinating that the top models in the world are only trained to information up to the end of 2022. So you're like most recent updates to GPT and Gemini, the data for the foundation model ends at the end of 2022, because from that point forward, there's no sense of whether the content was generated by a human or not, right? And if you train a model on outputs from models, it leads to model collapse. Everything reverts to mean. So
the models, to some degree, I think of as like they pull towards the centroid. They pull toward the center. They give you the most average answer to that thing. It's like Family Feud on steroids. And so you get that in inference, you get that in training, and if you give more of that kind of middling slop into the process that you're distilling the patterns out of, you get closer and closer to this boring, like HR corp speak kind of society, you know? And so yeah, you got to figure out how to get the interesting, novel things out of these and not have them just give you the most bland possible answer to whatever question you give them.
And being able to tie back and get interesting things. I mean, these are human things. Like these are distinctly human things. And knowing that it's generated by a human, I think it's going to be an incredibly challenging problem to solve overall. Do you mind talking just a little bit about common tools and what you're working on now?
Sure. So we're a seed stage startup. We're based in Berkeley. And what we're trying to do is unbundle the app for the AI era. So we think that if you apply AI to the way that software works today, you get kind of boring, hyper-centralized apps. We think that AI instead could help unleash a whole new class of software that is totally personal, perfectly personal, where your data you hold on your turf, and the software just kind of automatically emerges out of your data, helping you do whatever you're trying to do with that. And I think this is one of those things that sounds crazy because we're so used to in the entire industry that software is expensive to write and cheap to run. These are two fundamental assumptions that have been true for the entire software industry forever. Turns out LLMs undermine both of those because software that uses LLMs to execute has a marginal cost, is now no longer free, effectively. And secondarily, LLMs have made it possible to generate crappy, little simple bits of software for free, which radically changes the kinds of cost structures and what kinds of centralization forces make sense. And so we think that AI can be this unlock for not hyper-aggregation into one-size-fits-none apps, and instead into this perfectly personal world of co-creativity and control of your own data.
It's really wild because you think, too, like the greatest thing in my mind would be I'm a news junkie, reading through news constantly, and to be able to reference back like that direct lineage and sequence of things that I saw, I find would be one of the most interesting ways to augment like one's experience in one's mind overall. A lot of this requires almost this local processing.
Yeah, you have to have it if your data is somewhere else that you don't really have control. So like, if you use a lot of Google services today, and I worked at Google for 13 years, I think it's an amazing company, but as you put more and more of your data into these services, they have a fair bit of it on you. But they also, it's hard for them to add features. So like, say I was into tabletop role-playing games. I'm not, but I have a lot of friends who are. And let's imagine there's some amazing feature if they tied together data from Gmail and Calendar and Search into a thing that would change my life as a tabletop role-playing enthusiast. But there's no way Google would ever build that feature. Can you imagine as a product manager inside of the company, come up with this idea, and then you talk to 12 other product managers throughout the company and convince them to implement this feature, and each one of them says, how many more daily active users will I get? You go, I don't know, 50,000 maybe? And they go, I can't even count that low. So you get this, as more data centralizes, you get actually less value out of it. You get more of the lowest common denominator of one-size-fits-none kind of software. And that's where we are in the technology industry. And I think that AI, LLMs, are a truly disruptive technology. I think they change the cost of a number of inputs that has really interesting implications for what kinds of things can now be possible that we just didn't even know to ask for because we didn't know it was possible.
It also brings up, like, what is the value of the output from this, right? Because if you suddenly dilute everything, right, with content that's coming out or generated information, how do you then start valuing each incremental piece that's there? And if it is consumed only by one, versus something that can be consumed by many, how you manage that? A lot of it comes down to also the compute side. Like, what's the capacity? Who is going to have this? Where is it going to be?
And a lot of software, one of the reasons that software is hard to write and expensive is generalizing it. You have to make sure it works for lots of different situations, lots of different use cases, lots of different people. If you're going to have a piece of software that you're going to run a single time, it's fine. It can be kind of sloppy. It can be kind of duct taped together. It's fine. And that changes the structure or the kinds of things that you expect software to do, and it changes the kinds of use cases that are now plausible.
How do you think this changes the folks that are going into computer science right now?
I think LLMs change a lot of things. I think the people who use them most effectively are people who know how to use them and, again, co-create with them. It won't replace your thinking. It will replace it with a more general, sort of muddled, simple thing. But if you can use it to help lever your creative thinking and let you pull on threads more quickly or explore ideas farther, that's the kind of thing that will unlock quite a bit. So one of my good friends is Simon Willison, and he covers a lot of stuff about AI and has a very popular blog on this. And he constantly will now make little bits of software that would have taken him an afternoon to write, and now they take him 30 seconds. And so now he has all these little pieces of software that it would have never made sense for him to invest that time. And this is somebody who's a wizard. He built Django, the web framework, many years ago, and as an amazingly productive engineer. So I think seeing how you can change the way that you create, the kinds of things that you can create with it. If you assume this thing, you're going to give it a prompt, and you're going to say, build software that does this, and it'll produce a perfect bit of software that does exactly that, you're going to be disappointed. If you think of it instead as something that's going to help extend and allow you to think with higher leverage and move faster through the boring parts of the problem, I think you'll have a lot more from it.
I mean, we talked earlier, both Alex and I have 2 kids, each under the age of 5, right? And most of the time is spent with handing them phones to talk to GPT and like have these conversations back and forth, to like being able to create kind of whatever they want. And we were talking earlier, I find it fascinating, this idea of taking a child and never giving them a sense of constraint, like for creation. Like if you have a concept, like I want to make this thing and it's going to be a combination of this, this, and this, and then it suddenly appears, right? And that sense of like, can you do it? Yes, you absolutely can. You can always do this. Like what that means for almost like a generation of people that will come through.
Like when Adeline asks questions, she's super curious, obviously, and she'll ask these questions. And sometimes I'll be, not a finance dad moment, but I'll be like, oh God, I'll give her a short answer. But then I'll say, oh, I'll just ask ChatGPT. And she has a conversation with it for minutes, and she asks all these follow-up questions. And why do penguins not eat meat? And how come they don't fly? They don't fly. And it. By knowing it's, she's a 5-year-old, to make it appropriate for her level, she just knows that she can ask this thing that has infinite patience. I think it's one of the things that LLMs are great at is human-style common sense and sort of background knowledge of the world. They're very well read. They're kooky. They get the answers wrong sometimes, but they have infinite patience, and they never get tired of the question to ask. And that allows, just imagine having a conversation partner who knows so much about the world, who's never going to make you feel like an idiot, and is always going to be game for whatever thread you want to pull on. And I think that just changes the way that you think about learning and curiosity and discovery. And it's really cool to watch Adeline do that.
The thing I get a little nervous about it when it becomes more of like, here's the question, here's the answer, right? Like where is that process of trying to do diligence? And like, where did this answer come from? Is this answer legitimate or not? And that sense of like truth is also very complicated because there are very few things in the world that are actually like this or this, and it tends to be a spectrum. And
I think for factual questions with like a numerical answer, do not use it to get like for like general like vibes or kind of riffing on different ideas. I find it really useful. But
do you see it changing? I mean, like, do you see a path whereby like there is a mechanism to be able to create more of this? Almost just linkage back. I mean,
I think there has to be. I think this is where LLMs are clearly an extremely useful part of their extremely new useful material. I think of like magical duct tape. Magical duct tape on its own isn't particularly useful. The question is what you duct tape together. So it's like a thing that allows you to extend the possibility of thinking for a lot of things. That means, though, that there will be, I think, increased need for trust, for provenance of sources, for knowing the like supply chain of your information, and using the LLM not as an oracle that gives you the precise answer to the thing, but as the glue, as the magical duct tape, the human-style kind of common sense that can help you reason through and connect more formal systems of factual databases or sources or what have you.
What's your take on the hardware side? Because I like to, no offense, I do like to joke that mostly when I talk to software folks, they tend to view chips as like breadboards that suddenly got smaller. You know?
Is that not how it works?
Yeah, I mean, it's close. But I mean, what's your sense from a hardware side? Because you very much come from their software side of things. A lot of these folks here are very much like chips, hardware people, not breadboards. Like, how do you see the interplay there? Like, what do you view from a constraint standpoint? Because I think oftentimes as you go further into the chain, like so much of this is powered by compute. Like the amount of RAM I can have on a GPU, the number of those GPUs I can string together is going to dictate the amount of information I can actually put into my model. And those have a lot of constraints downstream. The other weird thing is like at each point upstream of it's you add another zero to the value that's created. And so like at the end of this application side, you have the highest value that's created. I think I was looking, Google, Facebook, and Microsoft made double what NVIDIA made last year in profit.
Wow.
Okay, and it was about $200 billion combined between them. Versus the 100 on the NVIDIA side. I think it was up through Q3 of last year, which also, to put that in context, is like 4 or 5 CHIPS Acts in a single year. And so there's a part of me also that wonders, like, is there going to be an invest that comes in more from that angle to be like, I'm computationally constrained in some ways for the first time because, you know, I can only put maybe less than 30 seconds worth of data that Google will generate on any given day into training data for a foundation model. Like how do you see the interplay between these?
It's funny, one of the strategic decisions that we made for this company is to specifically not train our own models, to use off-the-shelf models only. And I think a lot of people are today with AI are trying to figure out how to make their own particular fine-tuned model or specific to their particular area. And instead we said, no, we're going to treat LLMs as commodity. I'm going to assume that GPT-4 level intelligence becomes cheap, efficient, and easy to access and open source. That's a pretty good assumption, I think, at this point. And so what we're trying to do, the way that we're approaching it is taking that as a given, what are some of the things that now become possible in the way you build software or outside of that? The whole space of, what also has been interesting this last year, you know, like 12 months ago, it looks like the only game in town for GPT-4 level intelligence was OpenAI. And now that is absolutely not the picture at all. You know, there's 20, 30 different models, including some open source ones, that some of them which can run on a consumer machine that can give you a similar level of quality. That's just insane. You know, now that we know that these techniques work so well, helping tune them to squeeze more performance out of them is pretty significant. I have no expertise in that area. I just assume I'm watching all this amazing talent and capital swarming on this problem and trusting that this will continue to get significantly better. And so far that has played out well.
It's interesting. There's a feeling I get every time I go on Hugging Face and I download a model that I know cost them more than $100 million to train and can kind of go bananas with just this raw model. You know, and that's the goal. I mean, the goal is to give these away and to keep. I love
doing these models as little like holograms of like human culture and intuition, these little things that, you know, these little cheap things you can plug into stuff. My friend Alison Gopnik is a child psychology professor at Berkeley, and she has this frame of AI stone soup. And so the stone soup story is, someone comes, they make a soup out of just a stone. They put a stone into, they say, what would make this better is a little bit of a garnish. So someone adds a garnish. They say, this is great, but make it even better is if we added a slightly bigger garnish. And before you know it, someone's put a chicken in, it's an amazing soup, and someone says, wow, it's amazing, this soup, and it just came from a stone. And that's the way I think that tech is about LLMs. People go, wow, this transformer algorithm and a bunch of compute produces this amazingly intelligent thing. And it's like, no, it's just absorbing all of human culture that you threw into it. Like, that is where most of the interesting upside comes from. Transformers are just do an insanely good job at extracting subtle patterns out of very large data sets. And it turns out that if you give them all of human intelligence that we've thought to write down and replicate elsewhere, you get a really useful little thing that can reflect back really interesting things.
And it's wild to see. I mean, we look on the biology side of it, you'll see models that are created just taking like a base text to image model, and you can throw in a sequence, like an RNA sequence, and then get an image out of the RNA folding pattern on it, and get like remarkably good accuracy.
Insanely good. Just shockingly. As in, it feels like it's tapping into a secret structure of the universe.
Yeah.
That if you were just patient enough at plowing through this, you could figure out. And the LLM and the training process and even its inference process is patient enough to do it.
It's also interesting though, because not every space has the same volume of information that you can just kind of throw everything in and get it out. And
right.
We've talked before. I would build these models for my kids of like Batman and Iron Man and all these so that they can make superheroes. And one fun task was just to say, like, how does error propagate in these systems with smaller amounts of information? So if I take a fine tuning and I want to train it on like Adam West Batman, right, and take 10 pictures of Adam West Batman, I can get like 9 out of 10 pictures out that look like Adam West Batman. It's kind of impressively good. But if I change one of those pictures to a Batman Lego action figure, and then I change 2 of the 10, and then I change 3 of the 10, 100% of the output looks good from a distance.
Yeah.
But then when you get a little bit closer to it, 100% of the output is super creepy.
Yeah, you look
very, very bizarre.
To me, the distinction of like quality or rigor is the closer you get, the more compelling it gets. And AI-generated slop has exactly the inverse of that, right? Like, wow, it looks amazing. And the closer you look at the more you're like, the heck? That doesn't make any sense. Like that thing, like there's a finger missing. Or I was watching some AI-generated videos. I was at a Thai restaurant in Berkeley a few weeks ago. And there's like wall. It was just a TV. It was playing AI-generated Christmas scenes. And they looked, at the beginning, I was like, I had this, my lizard brain goes pretty, It's like, and then as I'm watching them, very distractingly, as I'm trying to talk to somebody, you watch the videos that were generated. Watching AI-generated videos is a trip because the model is trying to make sense of each frame to frame and interpret it and try to make it feel coherent without a real true world model per se. And so it sometimes just changes its interpretation of the scene and it will start evolving the video in a very different direction. So at one point there was like a scene above a little Christmas village and it was like the camera was like, coming in at it like this, and there was a little bokeh of like, the lens flare kind of, and it's for some reason at one point halfway through, it started interpreting the bokeh as big lanterns hanging in the sky. So now you started flying through these big orbs that were just hanging in the sky for some reason. It's like a very uncanny experience watching the AI struggle to understand what's happening in that scene. So you get a bunch of these oddities the closer you are.
It's very, very bizarre. And I want to thank you so much for coming out here and it's great to see you again in person. And huge round of applause for Alex. We're going to bring you back up, I think, for questions at the end. Okay. So if you can just like hang out and not go too far. And the next piece is actually going to build slightly on this. Like, the thing I really find fascinating is high quality information yields such amazingly good outcomes, and yet those little bits of noise cascade at such an extreme level. And it's a total privilege today to be able to talk about mTrust and to really start bringing this out publicly. It's something that Thomas and Harold and team have been working on for years, and we're at a really interesting point. And as I mentioned, as we look back at the history of our company, where we had such a strong piece of quality in physical goods and in materials and how that drove science, our goal is to bring this into the digital age. And with mTrust, we've built an IP portfolio and a product set and now a development kit that can immutably link the physical and digital world. And if you think of blockchain as being cool because it's this immutable ledger, it falls apart when you try to connect it to something real. And we saw with the NFT craze a couple of years ago, you'd have art going for tens of millions of dollars. And the way to show that it was this piece of art attached to the NFT was a piece of hair that was epoxied in the art. But that's not truly a one-to-one piece with the painting. And what we do is we look at both the tags on the objects that are being read, taking something called hash entropy enhancement. So the hash being the cryptographic signature combined with the entropy, or how difficult it is to remove from this object, to be able to create this one-to-one match and then trace it across a process. And this enables some really interesting things, looking at product passports and traceability. So being able to take a drug or a reagent and say, this came from this specific batch, this batch was tested on this device was last calibrated on this date using this certified reference material, and through the back of it. But it also enables token economies and the ability for machines to be able to communicate with machines and have some sense of root of where things came from. It's an extraordinary effort, extraordinary lift, hugely complicated set of problems that the team solved in looking at the physical objects, the verification, the digital twin. And our goal is to help build resilient value chains, to boost agility and eliminate bottlenecks, to enable these tamper-proof digital twins, these tamper-proof equivalents of the physical version using these cryptographic anchors and establishing a layer of cyber-physical trust and creating privacy-preserving digital ecosystems while safeguarding data. This matters because in order to have trust in AI, we need to know where the information came from that actually trained these models. And while a lot of the broad kind of generic LLMs have worked because they're across a broad corpus of publicly available information, most of the things that are critical for science and technology are not publicly available. And you need to know where this came from and what this was. It also allows the security of autonomous machines. So as we have full end-to-end processes where the machines can communicate with one another, machines are ruthlessly efficient at rooting out trust and statistical trust in the sense that this thing is actually this thing, much better than humans are. So getting it ready for a machine-to-machine world is critical, and also just to ensure data integrity and quality. It turns out, this might surprise people, building the blockchain backends is slightly complicated. And so one of the amazing things that the team did was take all of the infrastructure layer that was necessary to empower this, from the Web3 infrastructure to the registries and tokens to digital twins and signing services, and make it so you do not need to be a blockchain expert to be able to build applications off of it. And everything that has come out now is the technology bridge from the portal that basically allows you to configure whatever type of environment you want to run with sets of readers and sets of tags, and automatically tie it to the secure backend without needing to be a blockchain coder. Obviously, there are the APIs and SDKs, the scanning devices, this ability to rapidly deploy the tools, and data integration that makes it usable really across any application. This is a quick look at the console. I don't think I'll go through the whole piece, but again, everything about this was made to reduce the need to do hardcore back-end coding, to distill it down to, here's my line of code that I'm going to integrate into my application, and even to remove that layer completely, just to auto-build applications on the fly. And it was great to be able to talk to Alex here, because machines are getting better and better at auto-building, essentially, these application sets. And so to be able to have this underlying tooling becomes really interesting. All the documentation, all the guides are there. There's, I think, mtrust.io. You can see everything you need around this. Creating the application, simple as adding a name, adding permissions. Here's our registry. Setting your token and creating the app. You don't want to lose token. That's bad. But then you copy and paste the line into your code, and it's set. It's very similar to how Stripe did financial processing to be able to embed into websites, so without needing to rebuild everything from scratch. We have 2 readers that we're starting out with, and this is what we're very excited to introduce today. We have the developer kit that we're starting to accept essentially applications for invites to be able to start building. They're over here. Thomas and Harold can give you guys demos. It is some of the coolest stuff that's there. Form factor is fantastic. And the mtrust portal, which has all of the SDKs and APIs for folks to use. So with that, I really want to congratulate, the team for a heroic life. This has been, I think, 7 years in the making. They have over 70 patents now that have been granted in a number of territories. It's been just a great job. And so huge round of applause for Thomas, Harold, the mTrust team, everyone who's been a part of that. Extremely, extremely exciting to have this. And I'd like to introduce Laura to come up and we'll have a quick discussion around this. Laura Matz is our Chief Science and Technology Officer, as well as the CEO of Athinia. So welcome, Laura. Welcome.
Very exciting, and also my congratulations to the team. It's been a long time. It's been a long time coming. And honestly, I think, James, what I wanted to do in our discussion is maybe we can go back to the picture of the... Yeah, maybe chemisphere is a good one. So
perfect.
So I think a couple of things maybe we want to talk about in a little bit more detail. The first thing might be why Merck? Why Merck KGaA, Darmstadt, Germany? It maybe isn't obvious how we got here and why we thought this was a critical part of our journey. But I think you touched on it in the beginning of this history of sort of quality being in our DNA, and this now kind of coming full circle into the digital age. So maybe give a little more detail.
Yeah, and it's wild to go back, right? Because in 1668, we're the oldest pharma company in the world, but what was pharma at that time? Yeah, these were pharmacies, right? Where you had gardens behind the pharmacy, and you would go out and you'd pick your stuff and kind of collect it and get it together. And the real radical changes occurred when you started productionizing the creation of the individual components that you could ship out in bottles to different places. But I mean, you needed to know what was there, right? And this simple guarantee was obviously just it was a trust me letter, but it's wild to me that was only 170 something years ago is the first time we have at least some sense that I'm assuring you that this thing is this thing. I'm going to take some liability for that and have some guarantee behind it. And yet it is such a critical part of the scientific method and just scientific reproducibility at large. But I think for us, it's always been about not resting on your laurels, right? Because that was a trust me letter.
Right.
The company spent the next 100 years hiring the process engineers and literally writing the book on what it takes to ensure quality in the industrialization of chemicals. And I mean, this is a very natural evolution. The output of a scientific experiment is information. Right? And creating these tiebacks and the traceability back to like this data point came from an actual experiment that was physically done somewhere versus something that was just generated in the ether, I think becomes really existentially important for us.
So one of the things that was actually a good lead into the next question I had. So as you think about this technology, one of the fundamental shifts it makes is how we do quality assurance, right? And how we verify the product is the product and it has the right signature. And today, while we generate the data, it's in a digital format, there's still a person that downloads that data, reviews it, and then submits it into another database to verify, yes, this is the right data. I guess maybe can you describe how that changes with mTrust? Because I think this is fundamental to how the world will evolve in many different industries over the next 5-10 years.
It's a lot of trust me letters, that they're more formal, and we have more processes that we randomly audit. And I think it's almost a tightening of these boundaries around it. The sense that it's not a randomized audit, it's kind of an audit on demand at any point in time. I think the other thing is, as we look at where things are headed overall, it's not like I'm going to have a batch of medicine that is created for lots and lots of people. Right, where I can give you the same batch that I can give you, right? If I have a medicine that is coming off of a sample of my specific, biopsy that is going to have some specific sequence, and then the resultant treatment is specifically for that sample, I really, really want to be sure that the treatment I'm getting is that one, right? It's not something different.
Yeah.
These become, life or death. The failure risk is the cost of failure is very high.
Right. So one thing I think, as we've kind of worked on the preparation for the launch and all the work that the team's done to get this ready, I think one thing we've realized is how many different industries this can serve. So of course, for us, it can enable quality in electronics materials, it can enable quality in drugs, in life science. But there's also other industries that it can serve, and I think that's one of the fundamental things we're trying to do is launch this so that many industries can take advantage of the technology. So maybe give a little bit of background in terms of the broader industries that this can make an impact to, and how do we want to engage those industries?
I think maybe it's first admitting that we're not the experts in those industries, right? And so a lot of our time has been spent on how do we not have to do the lift to be able to get these in other sectors where it matters. I mean, food is a great example. We have the chicken has gone on tour with us for many discussions for many, many years, but like it is a fantastic example of scale and the need to have some kind of traceability back to say, where did this come from? And if something goes wrong, how can I have proper recalls, and how can I have all of the kind of regulatory side of this in place? Anywhere where your cost of failure is high, I think, is the earliest adopter. But again, our push is not to be like the purveyor of quality necessarily, as much as the enabler of quality. How do we create the mechanism so that folks can add quality and traceability across? And just to give you a sense of like how core this is to our business, if you look at the life science side of our business, we have hundreds of thousands of products, right? We have 50-something different versions of salt, sodium chloride. Why? Because some people need it 90% pure, some need it 97%, some need it 99, some need it 99.99, some need it 99.99999, plus whatever additional test that goes off of it. And this isn't the only space that matters, and especially like Alex is talking about the videos. As you look at these like generated videos, and you're like, something seems off here, right? That feeling of it feeling off is the uncanny valley. The sense of like, what is it between real and fake? This generated thing that is not there, and that uneasiness you have as you kind of like wade through it. And I think especially now we need some mechanism to navigate this. We need some route and map to say this thing is actually from here, this thing is actually real, we can trust it.
Right. So I mean, having worked on the importance of quality in electronic materials, I'm personally excited about this journey because I have worked through the standard verification, the verification of analytical, and to be able to really verify and know, yes, this data is the right data for this batch. And to be able to directly digitally transfer that to our customers, I think will be really, really enabling. But for me, what's also interesting is there are so many other industries like aerospace, food, as an example. And I think personally, my daughter will be very excited to know that we can now verify the chicken that she's eating is from a sustainable farm. And so there's many different opportunities here and many different customer bases. But I think the exciting part that we're trying to do today with the launch of mTrust is to really sort of let that go into many different industries and really sort of seed the technology so that it can enable quality digitally for many different products. And I think maybe one thing to kind of close, and then we'll take some questions. James, maybe give a little bit of the history of the journey. Like, how did we get here, and what did it take to kind of bring this to life? Because when you see the readers, it seems so easy. I think it seems like an iPhone 4.
Yeah. I mean, the journey started in 2016. I want to say after Sigma Aldrich was acquired, and we were trying to look kind of across these businesses that on the surface don't seem that interrelated, right? You have electronics, you have life science, and you have pharma. And then you have a pandemic that hits, and suddenly it totally makes sense when everyone is glued to devices and you need science to kind of get you out of it. But we had a set of lighthouses that we wanted to look at and kind of key bets that we wanted to make. And this really originated as one of those bets, the sense that we are going to need better mechanisms of validating that something is this thing, right? And you can see it from the trend side. And the good news is we had wildly persistent people who are incredibly smart and incredibly focused on getting this done. And the team has just done an extraordinary job in pushing this through.
So with that, maybe we would be happy to take any questions as well, I think. And Alex, please come up here.
I think A default feature for AI, people talk about AGI or whatever. I'm actually not worried about that. I think we're seeing clear topping out of models as we kind of run out of original material to train them on. But I worry that we're going to have AI is going to lead to a very samey culture of just everything just being boring and centroid and the same. And my hope is that it unleashes creativity. It allows people to be more expressive and collaborative and more authentic. But I don't think that feature is the default. I think that we have to work to make that happen. And I find, people when they use LLMs in an uninspired way get the most uninspired slop back. When you use them in a creative way, you can go much further than you would have gone before. And my worry is it's just easier to do the former.
It's fast. It makes me think. I would joke coming to CES for 5 years from like 2015 on was the sequence of like slightly thinner TVs with slightly thinner cables that went to them. And there was an exciting part here that we now have kind of like a new possible set of form factors that can emerge. But it is going to be fascinating to see like does this lead to convergence, because like that's what it is optimized to converge, right, at every point.
And I think if LLMs are truly a disruptive technology, and they seem to me to be disruptive in the same way of like electricity being disruptive, it takes a long time to figure out what to do with that. And so I think people are like, oh, we've figured out what to do with AI. No, we have not at all. We're like in the early innings. And I think that the people who try to make sense of what you can do with this stuff, I was telling James earlier, a friend of mine, that one of the former companies I was at, said they were inspired by me leaving to go do an AI startup, and that they had taken a sabbatical to learn about AI as an engineer. And I said, what did you do? And he said, well, it took 3 months, a ton of effort, and I got a little toy transformer running on my machine. And I said, that is the least interesting thing you could have done, because you just take these for granted that these exist. The question is what to do with them. What can you poke at? What can you get them to do? And that's something that even the people who created them can't tell you. And I think that there's we're just at the early stage of figuring out what you can do with this. I think I know a number of people have told me that LLMs are definitely, without question, useless. And anyone who's ever said that statement clearly hasn't used them a lot, because the idea that these will not change something large in society is impossible to me. And they're just so obviously, we just don't yet know what the best use of them is,
I have a question. So it worries me that we can't trace back our chickens right now with the technology. So what is the biggest differentiator that you see for the technology, and what the competitive advantage that this is going to give the marketplace and those that adopted and are early adopters?
Yeah.
I think at each level of additional quality and additional ability to accept liability, there's value that's there. It's easy to dismiss it as an anti-counterfeit play, and I think what's really unique is that it's take the concept of anti-counterfeit across every step of a process. And like what if I double checked and triple checked and quadruple checked at every single step of an entire process? And not only that, I'm checking the devices that are involved in each step of this process to ensure that it's working. It's that next level up. I like thinking of it as an audit on demand, because it's the ability to fully audit across everything in the value chain that happened. And we're certainly part of a business that additional quality yields additional value, but I feel like we're not alone in that. I mean, if you can't train an LLM on data past the end of 2022, like as simple as that, like there's a lot of value that's going to need to be there.
One thing I'll add to what James said, I think that the team has spent a lot of time over the past 2 years making the technology very straightforward to use, very easily adopted. You can see here actually in the demos, you basically turn the reader on and it's ready to go, and it connects to your phone. So that ease of use, I think, is something that will be differentiating and kind of enabling to proliferate, right? Because for this technology to take hold and for it to be usable, it has to be broadly applicable so that you can get traceability from the lab and individual analytical equipment, but then also you'd like to know, well, where did that material go in the warehouse? And you want it on scanners that can basically verify, yes, now it's in the warehouse. What's the shelf life? How long has it been there? So that sort of ease of use and kind of transparency across the entire value chain, I think, is something that we tried to design in so that when we launch, when we were at this point, it's basically able to be completely proliferated versus being niche in just one area. Yeah.
I also look at things like Lego Batman sounds really silly. I acknowledge that, you know? But the thing I find really interesting about that as just a thought experiment also is biology is 30% error. Proteins misfold 30% of the time. And if you take something where you infuse 30% error and noise into it and you have 100% error of output, that is kind of terrifying, right? And how you reduce that so that these generative kind of like builds on whatever was there before doesn't lead to this 100% error, I think is just super critical.
Okay, well, thank you everyone for joining us. This has been a journey that we've been on since 2016. I didn't realize it was quite that long, but the past 7 years have been really focused, and we're really excited to see now where the technology can go and what impact it can make. So thank you to the team. Alex, thank you so much for joining. A fascinating discussion, and honestly, you gave me a perspective on LLMs I didn't necessarily have before, but now I have something new to worry about, different than what I was worried about. And James, of course, you've been an incredible leader in this journey, so thank you.
Thank you so much. Thank you, everyone. Yeah.